Hi everyone, we are doing trial 1, working with calcium. So I'm going to give you some information about the conditions, so we'll be able to use that while calculating how many moles of gas we will evolve. Our room temperature. You're going to want to write this information on page 8. It's a large data sheet. And this is up right at the top. We're going to be using calcium. That's the metal we're going to be working with. Barometric pressure. So all this information is going up in the top left of your data sheet here on page 8. I am going to be pipetting our standardized HCl. This is the molarity of it. And I'll be pipetting in 25 milliliters into my reaction flask. I've labeled my reaction flask trial 1. And in your directions, it actually says transfer this reaction solution once it's done to a clean Erlenmeyer. I'm just going to titrate straight in this flask because I have many to use. All right, so I'm currently pipetting my 25 mils. And I'm going to transfer this into my clean reaction flask. This flask is a little damp, but it's okay because we're really analyzing the HCl content here. So as long as I know my standardization and how much I put in, it's okay if there's a little water in there. I'm going to use a little water to rinse off the sides when I do my titration. So that'll be good. So once I've transferred all of this completely, awesome. Can begin the reaction. So what I'm going to do is put in this, now I pre-weighed this mass for you all. I'm going to be putting this in to react with 25 milliliters of the acid. This is in excess. And then what we'll do is titrate to see how many moles of HCl reacted. And that's how we'll find our ratio. You'll find the moles of the calcium used using the formula weight. I've also pre-weighed a beaker. Which I will weigh after this to give you a mass of the water displaced, and this beaker. From that, you subtract and find how much water was displaced. Given the temperature of the room, you can figure out the density of water and then calculate how much volume-wise was transferred. Because the hydrogen gas that's evolved in this reaction is insoluble in water, the volume of water displaced will be equal to the moles, or the amount, the volume of hydrogen gas that's produced. Okay, so I'm going to swap this guy out. Remember to unclamp once this gets going. So we're going to start this in 3, 2, 1. And you'll see instantly the water begins to get displaced. So we'll let that go. I'll weigh this, and we'll be able to figure out that volume. Looks like it's almost done. Still going a little bit. And that looks like we're complete. So what I'm going to do, pinch this off, swap it back in, and now I'll mask this for you. So again, the pre-weighed mass right there, the mass of the beaker and water for trial 1, subtracting these numbers will give you the mass of water displaced. Using the density, you can figure out the exact volume. That concludes trial 1.